Hi students, I am your maths teacher. Enjoy the day with online class. Based on the set operations, we are going to see application on cardinality of sets. We already learnt about union, intersection, complement and difference of sets. We will apply this in day-to-day life. For that we have to know some results. The first one is n of A union B is equal to n of A plus n of B minus n of A intersection B. Second one is n of A minus B equal to n of A minus n of A intersection B. You will see in the Venn diagram also. Then third one is n of B minus A is equal to n of B minus n of A intersection B. And fourth one, n of A dash is equal to n of U minus n of A. Then some more results are n of A intersection B is equal to n of A plus n of B minus n of A union B. If A and B are disjoint sets, then n of A union B is equal to n of A plus n of B. Then n of U is equal to n of A plus n of A dash. You have to understand these results with the Venn diagram also. Then only you are able to do the practical problems. On this connection, we will see the first example 1.28. Here, if n of A is equal to 36, n of B is equal to 10 and n of A union B is equal to 40, n of A dash is equal to 27, find n of U and n of A intersection B. So, the formula to find the n of U is n of A plus n of A dash. If you substitute the value of these two, you will get 36 plus 27, which gives 63. Then n of A intersection B is equal to n of A plus n of B minus n of A union B. Substitute these three values, you will get 36 plus 10 minus 40. On simplifying, you will get 6. Next, we will see one more problem from the exercise 1.6. First sum, n of A is equal to 25, n of B is equal to 40, n of A union B is equal to 50 and n of B dash is equal to 25. Find n of A intersection B and n of U. Okay, first we are going to find n of A intersection B. Further, the formula is n of A intersection B is equal to n of A plus n of B minus n of A union B. If you substitute the three given values, you will get the value of n of A intersection B as 15. Then you have to find n of U. To find this n of U, the formula is n of B plus n of B dash. Here the value of n of B is 40 and n of B dash is 25. If you add these two, you will get 65. So we get those two values just by substituting the formula and simplifying the values. Next we will see the second sum. In this, if U is equal to x such that x belongs to n and x less than 10 and A is equal to 2, 3, 4, 8, 10 and set B contains 1, 2, 5, 8, 10, then verify that n of A union B is equal to n of A plus n of B minus n of A intersection B. To verify this, first we have to find the A union B. To get that, you have to write all the elements from A and B. So 1, 2, 3, 4, 5, 8 and 10. Now n of A union B is 7. Then to find the right hand side, we have to get the values of n of A, n of B and n of A intersection B. Here A is equal to 2, 3, 4, 8, 10. So n of A is equal to 5 and set B contains 1, 2, 5, 8 and 10. So n of B is equal to 5. Then A intersection B. Here the common elements between A and B are 2, 8 and 10. So n of A intersection B is equal to 3. So if we substitute these values in the formula n of A plus n of B minus n of A intersection B, we get 5 plus 5 minus 3 equal to 7. So from these two answers, left hand side and right hand side, we verified that n of A union B is equal to n of A plus n of B minus n of A intersection B. Like that we are going to do the third sum with the three sets. Here verify n of A union B union C is equal to n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of A intersection C plus n of A intersection B intersection C for the following set. Here the set A is A, C, E, F and H and set B contains C, D, E and F and set C contains A, B, C and F. Here from this given, we are going to find n of A. Here n of A is equal to 5 and n of B is equal to 4 and n of C is equal to 4. Next we are going to find A intersection B. The common element between A and B is C, E, F, and B intersection C gives C and F. A intersection C is equal to A, C and F. So n of A intersection B is equal to 3, n of B intersection C is equal to 2, and n of A intersection C is equal to 3. Next we are going to find A intersection B intersection C. Here the common element between these three sets is C and F. So n of A intersection B intersection C is equal to 2. Now for the left hand side we are going to find A union B union C, which is A, B, C, D, E, F and H. So the n of A union B union C is equal to 7. For the right hand side you are going to find n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of A intersection C plus n of A intersection B intersection C. If you substitute these values, you will get the answer as 7. So from this left hand side and the right hand side, we verified the above result that n of A union B union C is equal to n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of A intersection C plus n of A intersection B intersection C. Next we are going to see the application sum from the example 1.30. In a school all students play either hockey or cricket or both. 300 play hockey, 250 play cricket and 110 play both games. Find the number of students who play only hockey, the number of students who play only cricket, and third one the number of students in the school. So you have to find the three answers. For that first we have to assume that the number of students who play hockey as H and the number of students who play cricket as capital C. Now write the given values. N of H is equal to 300, N of C is equal to 250 and N of H intersection C is equal to 110. Then we have to draw the Venn diagram as in the figure. Then you have to substitute the given values 300, 250 and 110. Then you have to subtract this 110 with the H as well as with the C. So if you subtract this, you will get 190 and then 250 minus 110 gives 140. From this calculation we find the three answers. So from this Venn diagram, first you got the number of students who play only hockey, that is 190. Then the second one, the number of students who play only cricket, that is 140. Then the third one, the total number of students in the school, that is 190 plus 110 plus 140, which gives 440. Now we are going to do the same problem without using the Venn diagram. We are going to use the formula here. Here to find the number of students who play only hockey is n of H minus C. The formula is n of H minus n of H intersection C. So answer 300 minus 110 gives 190. Then the number of students who play only cricket is n of C minus H, which is n of C minus n of H intersection C. So 250 minus 110 gives 140. So that is the second answer. The third one is the total number of students in the school. Here n of H union C. For that the formula is n of H plus n of C minus n of H intersection C. So substitute these three values, 300 plus 250 minus 110, which gives 440. So we can do the problem in two ways. With this same concept, we will do the fourth sum in the exercise. In a class, all students take part in either music or drama or both. 25 students take part in music, 30 students take part in drama, and 8 students take part in both music and drama. Find first one, the number of students who take part in only music. Second one, the number of students who take part in only drama. And third one is the total number of students in the class. I am going to do this sum using the formula. First let us assume the students who take part in music as M and the students who take part in drama as D. So n of M is equal to 25, n of D is equal to 30 and n of M intersection D is equal to 8. These are the three given values. First I am going to find the number of students who take part only in music. For that, the formula is n of m minus d is equal to n of m minus n of m intersection d. If we substitute those values, 25 minus 8 gives 17. Second, we are going to find the number of students who take part only in drama. Further, the formula is n of d minus m is equal to n of d minus n of m intersection d. If we substitute those values, 30 minus 8 gives 22. Third, we are going to find the number of students in the class. Further, the formula is n of m union d is equal to n of m plus n of d minus n of m intersection d. If we substitute the values, 25 plus 30 minus 8 gives 47. Next, we are going to do the fifth sum. In a party of 45 people, each one likes tea or coffee or both. 35 people like tea and 20 people like coffee. Find the number of people who like both tea and coffee. Then second one, do not like tea, and third one, do not like coffee. In this problem, we are going to assume that the set of people who like tea as capital T and the set of people who like coffee as capital C. Then the given values are n of t is equal to 35, n of c is equal to 20, and n of t union c is equal to 45. First, we are going to find the number of people who like both tea and coffee. For that, the formula is n of t intersection c is equal to n of t plus n of c minus n of t union c. If you substitute the values, 25 plus 30 minus 45 gives 10. Second, you are going to find the number of people who do not like tea. For that, the formula is n of t dash is equal to n of u minus n of t. If you substitute the values, 45 minus 35 gives 10. And the third one is the number of people who do not like coffee. Here n of c dash is equal to n of u minus n of c. If we substitute the values for n of u and n of c, we get 45 minus 20 is equal to 25. Next, we are going to see the sixth problem from the exercise. In an examination, 50% of the students passed in mathematics and 70% of the students passed in science, while 10% failed in both subjects. 300 students passed in both the subjects. Find the total number of the students who appeared in the examination if they took examination in only 2 subjects. In this question, 2 things are given. One is the pass percentage, the other one is the fail percentage. So if we use the Venn diagram, we get the solution easily. So the first set denotes the max, the second one science, the rectangular box denotes the universal set. Here the percentage of students passed in both the subject is not given, so take that as x. Now subtract this x with 50, you get 50 minus x as the number of students passed in mathematics. Then subtract the same x with 70, you get 70 minus x as the percentage of students passed in the science only. Then the students failed in both the subjects is given as 10%. Place that in the universal set. Since the question is in percentage, if you add all these values, you will get the answer as 100. So you get 50 minus x plus 70 minus x plus 10 is equal to 100. On simplifying, minus x plus x gets cancelled. You will get 130 minus x is equal to 100. On transposing 130 to the right hand side, you will get minus x is equal to 100 minus 130 minus x is equal to minus 30, which gives x is equal to 30. In the question, it is given that 300 students passed in both the subjects. Here 30% of the students are passed in both the subjects. So 30% of total is equal to 300, which is total is equal to 300 into 100 by 3. So total number of students is equal to 1000. Hence we are at the solution. I hope you understand all the problems what we seen in this class. If not, watch it again and again and practice often. Then you will be clear. With this, we will wind up today's session. I will visit you in the next class with a new chapter.